guys, and welcome to lesson 5.13. We're going to talk about a special theorem with triangles called the mid-segment theorem. And it's exactly what it sounds like. We're talking about the middles of segments and how it's going to work with triangles. But first you have a warm-up. I want you to sketch or use these from your packet that you printed. You notice you have parallel lines, and we learned what that does, how it cuts triangles proportionally. So I want you to set up your proportions and solve for x. Pause the video and come back and check your work. Hopefully you found that x equals 9 in both cases. All right, let's get into that mid-segment theorem. So the triangle mid-segment theorem. First of all, the mid-segment of a triangle is a segment that joins the midpoints of two sides. So let's look at QR here and PR. These are two separate sides. This YZ, you see how it cuts QR into two equal pieces? You can see that by the notation. And it also cuts side PR into two equal pieces, meaning it's the midpoint. Z is the midpoint of PR, and Y is the midpoint of QR. And when we connect those two midpoints, we have a mid-segment. So there you go. That's what a mid-segment is. Now, a little property that we have with mid-segments here. It says that the mid-segments make it so that DE is parallel to AC. So your mid-segment is not only the midpoint of one side to the midpoint of the other, it is parallel to the third side that it's not connecting. The other thing they're telling you is it's like it's 1/2 of AC. In other words, if this was x in length, then this would be 2 times x in length. And if we want to just think of it in the reverse, draw this again, kinda. I'm going to say B, D, A, E, C. I'm going to make this a mid-segment. If this was x, this would be 1/2 of x. That's the way it's going to work either way. Let's just work through some examples together. So for example here, notice I've got, that's a midpoint. That's the midpoint, making this a mid-segment. So if that's 32, this is going to be 32 divided by 2. So CB equals 16 units. I've got a midpoint here, and I've got a midpoint here. When I connect them, that's a mid-segment. The mid-segment is 15, so this is going to be 2 times 15. So US would equal 30 units. Okay, now let's look through this example. I've got the AD is given to me as 6. Well, that means DC is 6 because they're congruent. And it says DE, which is a midpoint and a midpoint. So a DE here is 7.5. What are the lengths of DC? We've already decided was 6 units because it matched AD. AC is the full length here, so that's going to be 12 units. EF, let's think about EF. EF is this one and this one. This is a mid-segment, which is going to be 1/2 of 12. So it's going to be our 12 divided by 2. So it's going to equal 6 units. And then the length of AB. Well, if this is 7.5, then it's going to be, and that is a mid-segment, and AB is the side that's parallel to DE as a mid-segment. It's going to be our 7.5 times 2, so it will be 15 units. Okay, we're going to look at this one. We're trying to find the length of AC. Well, this is a midpoint, and this is a midpoint, making this a mid-segment. This mid-segment is parallel to AC, the side it doesn't connect, so this is going to be 2 times my 6.2 to find AC. So I'm going to have 6.2 times 2, and that's going to be 12.4. Let's see, am I looking at that right? let's go back here to our diagram. I'm actually thinking, now I'm looking at the diagram differently. I think they're saying that that 6.2 is here, making this, no, I was right the first time. The 6.2 plus 6.2 does not equal 17. 17 divided by 2 is 8.5 and 8.5. So yes, this has to be 6.2. So then AC, it's going to be our 6.2 times 2. So that's going to equal 12.4 units. Now up here it says to find BD. So I'm just looking from here to here. That's going to be half of our 17. So BD would equal 8.5 units. Okay, let's look at a couple more examples. We'll add a little algebra into it this time. So now I know from the notation that's a midpoint. That's the midpoint, making this a mid-segment. So 2 times this amount right here equals that. So 2 times x minus 4 would equal 20. Don't forget to distribute. Add 8 to both sides. Divide by 2, and x equals 14. Again, I'm looking at my notation. Here's the midpoint. This is a midpoint, making this a mid-segment. So 2 times my mid-segment is equal to the side that it's parallel to, the side it does not touch. Don't forget to distribute. I'm going to subtract 2x from both sides to keep my x's positive. And then add 8. And I have x. Okay, 2 more examples. Just ramping up the algebra a little bit more. Once again, look at the notation. I have a mid-segment. So 2 times my mid-segment equals the length of the side of the triangle that it doesn't touch, that it's going to be parallel to. Do not forget to distribute. Subtract 3x from both sides. Add 20 to both sides. And x equals 11. Final example. That's a midpoint. That's a midpoint, so this is a mid-segment. So 2 times my mid-segment is going to be equal to that third side of the triangle. Don't forget to distribute. I'm going to subtract 3x from both sides. Now I'm going to add 6 to both sides. Oops, I'm sorry, when I subtracted 3x. There's one. Caught my error. You can all make them. Let's go back and distribute properly. 2 times 2 is 4x. Subtract 3x from both sides. Add 6 to both sides, and x equals 7. And that's all we have for mid-segments. So if you have any questions or any concerns, be sure to get in touch with me through It's Learning, or bring your questions to class, and let's get everything straightened out. Hope you have a great night. See you in the next lesson.